Acid-base nomenclature, or naming acids. So remember, we're going to recognize our acids. They start with an H, and there's two kinds of naming. There's naming an acid that starts with an H and it's bonded to only one type of atom. And then there's acids with polyatomic ions, and there are two different rules for each of those. And so let's start with this. Our hydrogen and our one element, our binary acid. We always start those with the word hydro. And then we change the anion name. Instead of "ide," we change it to "ic." So, and then we say the word acid. So this is hydrochloric acid. Okay, why? Because this isn't a polyatomic ion, so we just start it with hydro. Here we have hydrogen bonded to fluoride ion, so it's hydrofluoric acid. Okay, we change the fluoride to "ic," ide to "ic." Here's a hydrogen and iodine, so that's hydro, can you do it? Iodic acid. Okay, and now we have hydrogen and bromine. So again, just two different, remember, even if there was a two, we still would say that this is two different elements, even though there's multiple of that. Okay, so this would be hydro, can you do it? Bromic acid. It's easy to recognize these more so than learning the naming. But now we have polyatomics, and you're going to recognize your polyatomics because they're going to have oxygen in them. Sometimes they're called oxyacids. And remember, with our polyatomics, you need to pull out your polyatomic ion cheat sheet. There are ates and ites, right? So we have sulfate and we have sulfite. And this is how you're going to remember. They changed the ending. Why? I'm sure just to mess us up and make it difficult, because like here we went I to ic. Okay, so here if we have ate is going to change to ic. How can you remember it? If you ate it, it's icky. Okay, and our ite turns to us. So this is nitrate. So it becomes nitric acid. Notice there's no hydro here. So with our polyatomics, there's no hydro. Okay, now this is sulfate. So it turns to sulfic, but it's actually sulfuric acid. There are some exceptions. Sulfuric acid. And here's HS. Now this is hydro, because there's only two, and that's a hydrosulfuric acid. So here's the difference. This has an O in there, so it doesn't start with hydro, and this does not. Okay, this is carbonate, so it's carbonic acid, and this is acetate, so it's acidic, acetate, acetic, acetic acid. Okay, because this is sulfate, carbonate, acetate, nitrate, ates turn to ic. And now we are going to look at our ites. Okay, so this is nitrite, this is nitrate, it turns to nitric. Nitrite, ite, turns to us, so it's nitrous acid. This is sulfurite. Okay, it's sulfite, so it turns into sulfurous acid. And sometimes there is just a little extra syllable and there's really no rhyme or reason. Like this should be sulfate, it should be sulfic, but it's not, it's sulfuric. Carbonate, carbonic, we call it carbonic, but you see there's just no rhyme or reason. Okay, so this is my chlorite, so it turns into chlorous acid. Okay, And this is hypochlorite. So it is hypochlorous acid. Okay. So this worksheet I'm going to post online because you're going to have a couple, it's going to have a couple of changes, but I am going to do 1 and 2 with you. So this is hydrofluoric acid. The name of the anion, remember that's the negative half or F minus, is going to be fluoride. And I changes to ic, so it's hydrofluoric acid. Okay, there's only 2 different kinds. Here I have that O, or it's a polyatomic, and that's my acetate. So C2H3O2 is acetate. And when you do this on your worksheet, you don't have to put this part here, okay? You just have to put fluoride acetate. And since it is a polyatomic ion, I don't use the word hydro, so it is acetic acid, okay?